The major applications of electrical circuits are electrical laundry iron and electrical toaster, that is we will be using for the bread toasting, right? In our home appliances we will be seeing that mostly in our kitchen. And the electrical oven, which is here we will be using that tungsten material on the surface of the heating plate, that is heated up but it doesn't melt. It is having a very strong melting point. Therefore we will be using this for the process of heating, and thus we will be heating up the food what we will be eating, and we will be seeing it mostly. And the electrical kettle and electrical heater, these are also the best examples which we will be using in our home. And we will be seeing these applications based on the heating effect of the resistors. That is, the resistors are of two types, that is static and variable resistors. And the variable resistors are called as rheostats. I will show the figure of the variable resistors, that is, it is having a variable, that means if at all you want 2 ohms of resistance, then you will be keeping the pointer across the 2 ohms. It is around the 0 ohms to 30 ohms range. That means we can change the resistance how much we need at particular condition. That is, the output is based upon the input, that is how we are keeping the resistance, that is 2 ohms. Up to 0 to 30 ohms we can change the variable pointer as we need. This type of resistors are known as rheostats, and rheostats are most commonly used in the home appliances. And the fixed resistors consist of only just 3 ohms, 30 ohms, that means it is a fixed. It is used for the particular purpose only. We can't change according to the system. And these are known as mostly control units, and they are also known as control units because they are controlling the resistance as per the condition, right? We will be knowing that in the controlling process in the higher classes, that is input, whatever input we are giving, the output is based upon the input, that is known as the controlling of the system. And here we will be controlling by the help of rheostat. Now in this process we will be seeing that electrical heating can also generate not only the heating but also the light also. That is the good example, that is electrical bulbs what we are using. And the strong metal, as I said previously, that is the tungsten, is used in the electrical bulbs also. And the gases which are used in the electrical bulb are mostly the nitrogen and the argon gases, which are inactive, that is they are chemically inactive gases, that is inert gases they are said to be, that is helium, neon, argon, krypton, all those are inert gases. And these inert gases are mostly used in order to avoid the chemical compositions of the gases. Now we will be using the iron board, that is electrical iron box. For example, let us take electrical iron box. In this also the resistors which are used will be consuming larger amount of heat. Thereby we will be producing the output, that is heat energy. And the electrical iron bars will consume, that is mostly when we iron down clothes, the output what we will be seeing is the amount of current will be high, because the electrical energy is mostly consumed by the iron boxes and the electrical heaters. These two equipments in our home appliances will be consuming a lot of energy, that is around 1 kilowatt electrical power for a 220 volts of supply. That is, it alone consumes 1 kilowatt power. You can assume that how much energy is consumed by only electrical heaters and irons. Now let us see the electrical power. What is power and how the power is defined for electrical circuits. Power is classified as shown earlier in the basic circuit diagram, that is, this is known as the basic circuit diagram, where the resistance offered is R1 and the voltage across the resistance is calculated with the help of the voltmeter, and the current passing through the resistance is calculated with the ammeter in series connection with the resistor. Now here we will be using the cell or battery for the charging up of circuit, right? And here we are giving the 220 volt supply. This is the basic electrical circuit, and here we will be calculating the amount of power consumed as the product of voltage and current, right? And it gives us that is VA rating, and that is voltmeter rating, and ammeter reading, that is V and A. That is, we will be saying that amperes for the current, and voltage it is volts. The units are VA, and power units are watts. The SI units of power is watt, and 1 watt is defined as the amount of voltage or the 1 volt passed through the electrical circuit, and which absorbs the 1 ampere of current. That is 1 watt equals to 1 volt into 1 ampere. It gives us the 1 unit of watt, that is 1 unit of electrical power consumed by the circuit. Now we will be seeing the 1 kilowatt hour also. Kilowatt hour. 1 kilowatt hour means 1000 watts. That is 1000 watts into 3600 seconds. We will give us the 1 kilowatt hour, that is equals to 3.6 into 10 to the power 6 kilowatt seconds, that is converted into 3.6 into 10 to the power 6 joules. That is, the other unit of watt second is joules. This is the SI unit of energy consumed by the electrical circuits, that is joules. Joule is the SI unit of electrical circuits, right? And we will be seeing that P is equals to VI as shown in the figure, and now P can be written as, that is the power consumed or power dissipated across the circuit is defined as P equals to VI, and V is nothing but IR. Now we will be substituting this in the first equation, that is P equals to VI, and we will be getting IR into I, that is equals to I square R. P is defined as the square of the current produced or generated with the product of the resistance. Now we will be seeing the amount of power in another form, that is V equals to IR, I equals to V by R is substituted, that is V by R. Now here we will be getting V square by R. So the amount of power dissipated across the circuit is defined as the voltage, the square of the voltage by resistance, or the product of the square of current and resistance. Now we will be solving one problem in order to understand the power dissipated in a circuit. Now let us solve two problems in order to understand the power and the amount of energy dissipated. Here we will be seeing the question such as 100 joules of heat is produced each second in a 4 ohms resistance. Find the potential difference across the resistor. That means there is a resistor. Assume this is a resistor, and the amount of resistance offered by the resistor is 4 ohms, it is given, and the amount of energy done, that is the work done in order to move the charges from one point to the other point, is 100 joules. That is, it is resulted in the form of heat. Now we will be calculating the potential difference across the two endpoints, that is V. We have to calculate V across the two endpoints. Now we know that according to Ohm's law, V equals to IR, right? And we know the amount of heat energy dissipated is H equals to P into T, that is power into time, and power is defined as P equals to VI, and therefore we will be getting V into I into T, that is heat dissipated. And now we will be substituting for V as IR, that is from first equation, that is H equals to, in the place of V we will be giving IR, then I into R into I into T. Here we will be getting I square RT equals to H. From this we will be finding out the current, amount of current drawn from the circuit, that is I square equals to H by RT, right? Therefore I equals to root square of H by RT. So here we are getting the formula for current, that is I equals to root H by RT, and H is given as 100 joules, the amount of heat dissipated, that is H equals to 100 joules, taken as each second. Each second means per second, that is t equals to 1 second. Now we will be substituting all these values in order to calculate the amount of current drawn by the circuit. That is, here we will be seeing I equals to root of 100 joules by resistance offered is 4 into 1 second. That is nothing but 25 by 2. That is 0. That is 25 by 2. It is 2 ones are 2 twos are and 12.5 amperes of current. 12.5 amperes of current is drawn from the circuit. Now we will be finding out the potential difference. That is V equals to IR. V equals to I, how much amount we got? That is 12.5 amperes. So 12.5 into resistance offered is 4 ohms. We will get as 4 pi's are 20, 4 2's are 8 and 8 plus 2 10 and 4 1's are 4 pi. And here we are getting 50 volts of potential difference across the resistors. I hope you understood how I derived the formula for I. And after getting the current, we have calculated the potential difference across the resistance. Now let us see another problem, that is an electric bulb is connected to a 220 volts generator. That is, we are having a generator and we are connecting a 220 volts bulb across the generator. Now the current is 0.50 amperes. That is, the amount of current withdrawn by the bulb is 0.5 amperes, and we have to calculate how much power is used by the bulb. That is, power is known as V into I. It is a product of voltage and current. Therefore, how much voltage it is given? That is 220 volts. And the current is 0.5 amperes, right? And that is 220 into 0.5. It gives us 5 zeros are 0, 5 twos are 10, carry 1, and 5 twos are 10 plus 1, that is 11. That is 110 watts. That is SI unit of power is watts. So we will be placing 110 watts or 110 joule per second. By this we are concluding the electricity and how the electricity is dissipated in a circuit.